Hey everyone. Today we're going to go over how to solve a linear equation using the Jacobian method. So first off, we're going to start with, what is a linear equation, and, why would we want to solve one of those? Then we'll go over the algorithm, so which algorithm we use, so we end up using the Jacobian method. There's a few other methods you could do this with, but we're going to go with Jacobian. So this is a walkthrough of the actual steps that, we're going to go through. However, first we're going to start off with, basically the basics. So let's imagine we had, some matrix A, and it was multiplied by some vector x, and we wanted to know, B, which was a vector. So that would look something like this. It would be A0, 0, A0, 1, A1, 0, A1, 1, and that would be multiplied with x1 and x2. And that would equal B1, B2. So theoretically, in most problems we would know this and we would know this, but, x1 and x2 would be a question mark. So the question is, what's an effective way to solve this? So let's first write this out completely. So if I take A0, 0 times x1, so I'm just doing the dot product between this vector and this matrix, plus x2 times A0, 1 equals B1. So our goal is theoretically, let's first try and solve for x sub 1. So to solve for that, we would subtract this x2 times A0, 1 on both sides, and you'd get A0, 0 x1 equals B1 minus x2 A0, 1. And then we would have to divide by A0, 0 on both sides because we want to get x by itself, A0, 0. And this would give us x1 equals B1 minus x2 A0, 1 all over A0, 0. We could do a very similar thing for x sub 2. So it would be B2 minus x sub 1 A1, 0 all over A1 of 1. So this would be how, this is what we're trying to solve for, basically. The issue with this is if we don't know x1 and x2, what are we supposed to do? So in order to, what the Jacobian method is basically we say like, oh hey, let's guess, or let's say initiate x2 equals 0, and then also in this equation initiate that x1 equals 0, and then solve this, because theoretically we should know A1, A sub 0, we should all know all these. So we solve assuming x2 equals 0, and once we solve for that, we sort of do it again. So theoretically, let's say x2 example. So let's say we solved this equation, and we get a new x1. So the new x1 would theoretically, so let's say x1 sub new, would go, so let's say we'd use that again to solve x2. So x2 equals, let's get rid of that. x2 equals b2 minus x1 new, a1, 0, a1, 1. So this would be the next step. So we would, keep on iterating. So we would do step 1, and then we would iterate, and we'd get a new x1, and then we'd iterate, get a new x1, and a new x2. So we'd theoretically do both of these, update the new value, and continue from there. The full equation, so theoretically this would be the full equation for a 2x2 matrix, but we want to be able to do it for any. So theoretically this would be x of I, that's an ugly x, equals 1 over a I of I b sub I times b sub I minus the sum where I does not equal j of x I, let me make sure, x of j times I of j. So that would be the full equation. You could see it up here, a little neater. So now we're going to go through how to actually program this. If you want to try to program this by yourself, you could, check out my site. It's called DeepMLE. The full description is in the link below. Have a try, see how you do. But for now, I'm going to actually walk through the code. So, last warning. And here we go. So this is the solution on the site. So we're gonna walk you through the how it's actually done. So first off, let's assume you had a matrix. So this is matrix A, and that'd be 1, 2, 3, 4, and you'd have some B, which would be 1, 2, and you'd have some N. This is the number of iterations. So theoretically, let's say you did that loop process we spoke about earlier 10 times. Okay, so first things first, we'd get the diagonal matrix of A. So that would look in our example. So D of A would equal 1, 0, 0, 4, so just the diagonal points. And you're going to see why this is useful, later on in the code. And then we would also get D, or NDA, as I called it, which is basically everything that's not on the diagonal. So this would be 0, 2, 3, 0. And we would set our initial, guesses to x at 0. So x would be 0, 0. And this would have the length of b, and in this case, b is probably looks more like this, 1, 1. So it would have the length of b. We also have a x hold. We use this for the update process, but you'll see it later on in the loop. So first off, we say how many iterations would you like to do. We take the n over here. In our example, we said it was 10, so we want to do this iteration 10 times. Then we go, okay, let's look at how many elements are in A. So in our case, this would look more like this in Python. There's 1, 2, so there's 2 elements, so this would be 2. And we would say, okay, so for the first new value of x, so x hold, we take 1 divided by dA of I, so that would be the diagonal element right here. So theoretically, the diagonal element wouldn't be in a matrix form. It would actually be in a list form. So it'd be 1, 4. So we would theoretically take the first element. So this would be 1 divided by 1. And then we would take b sub I. And in our case, we said that was 1. Because up here, we said it was 1. And then we would take NDA, which was the values of the so anything not considered a diagonal, we took from there. So we would take this list of numbers, and so it'd be 0, 2, and we'd multiply it with x, and x would be, in our case, where we initiated at 0, 0. And this process would give us our first estimate for x, in this case sub 0. And then we'd basically do this another time, get x sub 1. Now the reason we have, basically this matrix right here, is let's say we had a bigger, we had a 3 by 3 matrix, so 1, 2, 3, 4, 5, 6, 7, 8, 9. We would theoretically, for this operation right here, we only want, it's not supposed to have these values. So in order to get rid of those, we make the matrix, NDA. This way it has no diagonal matrices, and we could do this simple operation in order to compute this part. Okay, moving on. Once we update each of the x holds or each of the xi's. We update them officially, and then we go through the next iteration. And we keep on doing this until, the number of iterations is done. And then we return our results. In this case, we round it to 4 just because for on the website end, we just ask you guys to round it to 4 for simplicity reasons. Also, we make it into a list for the, simplicity reasons on the website end. But yeah, this is how you would solve a linear equation using the Jacobian method. If you like this, I have other videos. You can check out the website for problems like this and other machine learning problems. Hope you guys enjoyed. Have a good day.